We covered how to solve trigonometric equations in loads of detail in year one, so go back to those videos if you need to, starting from simple trigonometric equations part 1. And in this chapter they're the exact same, except degrees are replaced by radians, and you have to give your answers in radians. So here's an example where we need to solve the equation sin of x is equal to root 3 over 2 in the interval 0 to 2 pi. And if you want to think about this in degrees, this is in the interval 0 degrees to 360 degrees, like this. Now, they could ask this question in an exam paper either in degrees or radians, and the giveaway is the interval and if it involves pi. So this interval here, 0 to 2 pi, as we've got this pi here, that is an indication that they want you to they want you to give your answers in radians. They may also just say in the question, give your answers in radians or give your answers in degrees. Another indication is if it's in degrees, the interval will have these symbols here, which means degrees. If it doesn't have these symbols, like this question, it doesn't have these symbols here, that is an indication that they want you to give your answers in radians instead. So the method here for when you're doing it in radians is the exact same in year one, and there's actually two ways you can do it. The first way is you can work in radians directly, or the second way that you can do it is you can work in degrees, and then when you do all the working out and you get your final answers, just convert the answers from degrees to radians. Now, if you're not that comfortable with radians, it's perfectly acceptable to work in this method here. I personally do this one because I've been working for radians for quite a long time, and I kind of think the more questions that you do in this topic, you will probably naturally start to come over to this method here. But if you're not comfortable in radians, it's perfectly acceptable to work in this method here. In this video, for the first two example questions, I'm going to show how to do it for both of the methods. After that, I'm just going to do it for this one here. But again, whichever method you prefer is fine. So let's start by working directly in radians. So we need to solve this equation here. Sin of x is equal to root 3 over 2, like this. So the first thing that we need to do is we need to do the inverse sin of roots 3 over 2. Now, because we're working in radians, make sure that your calculator is in the radians mode. I talked about what this is in the radians basic video, the first video in this chapter. And if you put this into your calculator, you'll get out a value of pi over 3. So what we then need to do is we need to sketch a graph of sin of x. So I've just really quick drawn a pair of axes using a ruler, and we need to sketch the graph of sin of x in the interval 0 to 2 pi or 0 to 360 degrees, whichever way you like to think about it. This isn't that important, we just need to do it really briefly. It doesn't need to be a work of art, they're not really going to mark us on it. So sin of x looks kind of like this, where it comes down like here, and then it comes down like this, then up like this. This is in the interval 0 to 2 pi, where this is 0, this is 1, this is -1, and this here, because we're working directly in radians, this isn't going to be 90 degrees, this is going to be pi over 2. This isn't going to be 180, this is going to be pi. This isn't going to be 270, this is going to be 3 pi over 2, and this isn't going to be 360 degrees, this is going to be 2 pi, like this. And then we are going to find where root 3 over 2 is. Again, it isn't important really where we say it is, it just needs to be some sort of positive value. So I'll just say root 3 over 2 is about here. Again, it's just for working, it doesn't matter too much, it doesn't need to be to scale. So therefore, let's draw a line like this, and we can see that in the interval 0 to 2 pi there are two values in which sin of x is equal to root 3 over 2, here and here. Okay, we already know this value here because we figured it out by doing the inverse sin of root 3 over 2. This value here is pi over 3. Okay, but what is this value here? Now again, we talked about this in year one, but I'm going to go over this again quickly. The way that we can figure out this value is because trigonometric graphs are symmetrical. So what do I mean by this? Well, this value here is 0, and this value here is pi over 3. So what we can do is we can figure out the difference between here and here as pi over 3 minus 0, which is just going to be pi over 3. So why is this important? Well, it is because the difference between this point and this point here and this point is at pi. The difference here is going to be symmetric, so it's also going to be pi over 3. So the distance between here and here in terms of the x value is going to be pi over 3. So therefore this value here is going to be pi minus pi over 3, which is equal to 2 pi over 3. So therefore this value here is equal to 2 pi over 3. And now we have the two solutions to the equation. So it is that x is equal to pi over 3 here, and that x is equal to 2 pi over 3. These are the two solutions, and then this is the answer. So that's if you work directly in radians, and then the second way you can do it is if you directly work in degrees, if you prefer it like this, and then convert your answers at the end to radians. I'll go through this really quickly because it's basically the exact same thing. So sin of x is equal to root 3 over 2. Make sure that your calculator is now in degrees, because now we're going to be working in degrees. So the inverse sin of root 3 over 2 is equal to 60 degrees. So I've quickly drawn a sine graph, but now it's in degrees instead, with a 90, 180, 270 and 360, and we'll say that root 3 over 2 is about here. And we see that there are two solutions again, with this one here already being the 60 degrees. And we know that the difference between this point and this point therefore is going to be 60. And we see that the other point is here, and therefore the difference between this and 180 is also going to be 60. So therefore it's going to be 180 minus 60 is equal to 120 degrees. So therefore the two solutions in degrees are going to be 60 degrees and 120 degrees. And then all you just need to do now is convert these degree values into radians. I talked about how to do this in the radians basics video, the first video in this chapter. All you just need to do is take the value, so 60 here, divide it by 180, and if you do that you get a value of 1 over 3, and then just stick a pi on the end like this. Another way you could write this, so it's like this value here, it's the exact same. You could write this as pi over 3 as well. And then for the 120, you do 120 over 180 is equal to 2 over 3, and then just stick a pi on the end, so it's 2 pi over 3. So therefore x is equal to these two values, pi over 3 and 2 pi over 3, and you can see that we have got out the exact same value. So whichever method you prefer, do either one, and it's just how comfortable you are in radians. It's your choice which method you do. Now, I talked about this in year 1, but I'm going to go through it again here because I think this is a really, really useful tip. There is a really powerful way that you can check your answers to trig questions to see if you've got them right. And it works for either method, because obviously we've got the same values out, is by putting these x values back into this equation here and seeing if you get the root 3 over 2 out. So what you're just going to do is you're going to sub these x values in. So we're going to do sin of x, which is pi over 3, and sin of 2 pi over 3. And if you put these into your calculator, obviously we're working in radians for both now, so make sure your calculator is in the radians mode, you do get out a value of root 3 over 2 each time. This is a really, really powerful way to make sure that you've got the answers right. And you can basically do it for any trig question. Obviously this is a really basic trig question, but for literally any equation that this is and any output here, if you just sub the value of x in, then you can get, and if you get out the value that you're expecting, you know that you've got the answers right, and therefore you can move on to the next question knowing you haven't made any mistakes. It's really, really powerful. I always recommend it. So here's another example where we need to solve the equation 2 cos theta minus 1 is equal to 0.5 in the interval minus pi 2 pi. So in degrees, that's minus 180 degrees to 180 degrees. So this is the last example in which I'll do both methods. So firstly, you can work directly in radians if you're comfortable with radians. So this is the equation that we need to solve here. So it's 2 cos theta minus 1 is equal to 0.5. Move the minus 1 onto the other side to do 2 cos theta is equal to 1.5. Then divide both sides by 2 to get cos theta is equal to 0.75, like this. And then what we can do, we can do the inverse cos of 0.75. Remember that your calculator needs to be in radians because we're working directly in radians, and if you put this into your calculator you get out a value of 0.72. And now I've just drawn a quick pair of axes here, so we need to draw the cos graph for minus pi and pi. So the cos graph looks like this, where it comes down like this and then it comes further down to a minimum like this, and then on the other side it's the exact same. You should know how to draw the sin, cos and tan graphs off by heart, like this, and then it comes down like this, where this is 1, this is minus 1, this here is pi over 2, this here is pi, this here is minus pi over 2, and this here is minus pi. Okay, so this is the equation that we need to solve here. So it's cos theta is equal to 0.75. So let's say that 0.75 is about here. And in this interval, we can see that there are two solutions. We already know this one here. This one here is the 0.72 that our calculator gave us. And this one here, again, we can figure out using symmetry. This one's a lot easier because the symmetry is down the y-axis. So this here is also going to be 0.72, but it's just going to be minus 0.72 like this. They're both based around 0. So the theta values to 2 decimal places, as the question asks, are 0.72 and minus 0.72. And then instead, if you want to work in degrees and work 2 radians, I'll go over this really quickly. The rearranging to cos theta is equal to 0.75 will be the exact same, and you take the inverse cos of 0.75, which now we're in degrees, put your calculator in degrees mode, it should give out a value of 41.41. And then again, draw a really quick cos graph, and 0.75 will say it's about here. So you can see that we've got two solutions. This one's the 41.41, and therefore, because of symmetry down the y-axis, this one's going to be minus 41.41. So therefore, theta is equal to 41.41 and minus 41.41. And then finally, we just need to convert these degrees into radians. So again, we divide by 180 to get 0.23 for 41.41. I know we wrote it in terms of pi last time. We only really do this if it's an exact fraction. If it's a decimal, instead what we do is we normally times it by the pi, put this into our calculator, which is equal to 0.72, and then we just leave the answer like this, kind of the pi incorporated into the decimal. And then minus 41.41 will be minus 0.72 like this. So therefore theta is equal to 0.72 and minus 0.72. You can see that we've got the same answer. So for the rest of the video, I'm only going to use the just working in radians method just to save time in the video, but you can use whatever method you want to if you are more comfortable working in degrees and convert to radians at the end. And again, I'm going to keep saying this, a really good way to check your answers is to put your theta values into the equation up here. So it will be 2 cos of 0.72, you do this for both methods, minus 1, and 2 cos of minus 0.72 minus 1. And if you put these into your calculator, you won't get exactly 0.5 because we rounded it to 2 decimal places, but you will get a value that is very close to 0.5, and that is a good indication you've got the answer right, and you can go on to the next question. So here's another example. This time we've got an inside the function transformations with these threes inside the functions here. Now we learned how to deal with these in the harder trigonometric equations videos in year 1. So go back to those if you need to, although I'll go through how to do it here. The key to this is we need to adjust this interval. At the moment this interval is in terms of theta. So at the moment this interval is 0 theta pi. And we need this interval not in terms of theta, we need it in terms of 3 theta, like this. So we need to multiply everything here by 3. So this theta will become 3 theta, like this. The 0 will still be 0 because 0 times 3 is still 0. And then the pi will now become 3 pi. And we have to work in this bigger interval here. And now we can just solve the equation here. Now, at first, this equation looks quite difficult because we have two trigonometric functions. But the key to solving this is remembering the identity that sin x over cos x is equivalent to tan of x, like this. And the reason this is important is, so let's write this out. So sin 3 theta is equal to 0.8 cos of 3 theta, and we can divide both sides by cos of 3 theta. So on this side it's sin of 3 theta over cos of 3 theta, and this side is going to be, so this cos 3 theta cancels out, so now we're just left with the 0.8, and then sin 3 theta over cos 3 theta is equal to tan 3 theta. It doesn't need to be x here. All that matters is that these two values are the same. And we've got the 3 thetas here. Sin 3 theta over cos 3 theta is equal to tan 3 theta, which is equal to 0.8. And this is in a format that we can easily solve. Now, really quick, if cos of 3 theta, if cos of 3 theta is equal to 0 was a solution to this equation, we would not be able to do this because we would not be able to divide by cos of 3 theta. So we would essentially be dividing by 0 if cos of 3 theta is equal to 0 was a solution. But this is not a solution. Now, it's kind of difficult to understand, right? But the reason is because if cos of 3 theta equal to 0 was a solution, then this side would be equal to 0. And in order for both these sides to be equal to each other and for this to be a solution, this side would need to be equal to 0 as well. And there is no single value of theta for which both sin of 3 theta and cos of 3 theta are both equal to 0 at the same time. This is the same for just theta as well. There is no single value for theta for which sin of theta and cos of theta will be equal to 0 at the same time. So therefore, cos of 3 theta equal to 0 is not a solution, so we can divide by cos of 3 theta. So we've got this equation here, and then we do the inverse. So we do that the inverse tan of 0.8, making sure your calculator is in radians mode. If you put this into your calculator, you get a value of 0.675. So I've quickly drawn a pair of axes using a ruler, and therefore we need to draw the tan graph, and we need to do it in this interval here between 0 and 3 theta. So it's quite a big graph. We have to do quite a lot of it. So tan, remember, it kind of comes up like this here, and then something comes down from here and meets the x-axis. It comes up like that, and then another one comes up like this here, and then one more comes down like this here. So this here is going to be 0, this here is going to be pi over 2, this is going to be pi, this here is going to be 3 pi over 2, this is going to be 2 pi, this here is going to be 5 pi over 2, and this here is going to be 3 pi here. There are asymptotes here, but we don't really need to draw them in. It's not that important. Again, we're not really marked on the graph. This is just more for us trying to figure it out. So this is the radian graph here. Again, it doesn't need to be too accurate. And we want it to equal 0.8. So we'll say 0.8. Again, it doesn't matter too much. Just say it's like here. And we can see that in the interval between 0 and 3 pi, there are 3 values that equal 0.8. This one here, we already know, is the 0.675, sorry. And again, we use the fact of symmetry. So what we do is we know that the difference between this point and this point is 0.675. And therefore, you can figure out the difference between this point and this point as well is also going to be this 0.675. So therefore it's going to be this point here is going to be this pi here, pi plus the difference here, which is 0.675 because of symmetry. And if you put this into a calculator, you get a value of 3.817 like this, and then this value here is going to be 2 pi plus, and then it's going to be the difference here again, 0.675. And if you put this into a calculator, this is equal to 6.958 like this. So these are the three values: 0.675, 3.817 and 6.958. And this is kind of why we draw the graph, is so we can see this symmetry here of this constant differences here of how we can get these values. Now this is what 3 theta is equal to, so this is what we've solved for, 3 theta. So 3 theta is equal to 0.675, 3.817 and 6.958. So I just had to clear some space and I made this a bit shorter. So this is what 3 theta is equal to, but we want theta as our answer. So all we have to do is just divide each of these individual numbers by 3, because this is what 3 theta is equal to. So if you think about it like a rearranging an equation, it would be 3 theta is equal to 0.675, for example. So then you divide both sides by theta to get whatever this is divided by 3. So you divide all of the values by 3, so it's 0.675 divided by 3, if you put it into a calculator, is equal to 0.225. 3.817 divided by 3 is 1.272. We need it to 3 decimal places, as the question states. And then 6.958 divided by 3 is equal to 2.319. You can check if you want. All of these values lie in this interval here. So these are the final answers. Theta is equal to 0.225, 1.272 and 2.319. Now again, as I said before, a really good powerful way to check your answers is by subbing the theta values back into this equation. This one's a bit more tricky because theta is on both of the sides. The way that I would do it is, so for example, the theta value of 0.225, I'd first of all do it for this side, so it'd be sin of 3 theta, which is 0.225 like this, and then put this into the calculator, and then I would put this into the calculator, so 0.8 cos of 3, and then the theta value, which is 0.225 like this. And if you put both of these into the calculator, you get out the same value, 0.625 and 0.625. They equal each other as they need to in the equation when you get the values of theta. That's actually what you're trying to do. You're trying to find the values of theta in which both sides of this equation equal to each other, and therefore you have found a value of theta in which both sides of this equation equal the same value. So that's what you need to do, and that's a really good way in order to check your answer. So here's another example where this time we've got an inside the function translation. Now because it's an inside the function translation, this is given in terms of radians, and this value here, if you want to think about it in degrees, is 36 degrees. So in order to solve this equation, firstly we need to adjust the interval again. So at the moment it is 0 and then theta and then 2 pi, and we need to adjust it to this. So what we need to do is we need to add pi over 5 to all of the values. So it's going to be theta plus pi over 5 like it is in the bracket. 0 plus pi over 5 is pi over 5, so this will change from 0 this time, and then 2 pi plus pi over 5 is equal to 11 pi over 5. So this here is the new interval. So let's solve this. So this is 2 cos of theta plus pi over 5 is equal to -1. Divide both sides by 2 to get rid of this 2 at the front. Get cos of theta plus pi over 5 is equal to -1/2, and then we do the inverse cos of minus a half, which if you put it into your calculator and your calculator is in radians, you get the value of 2 over 3 pi. So I've quickly just drawn a pair of axes with a ruler. So we need to sketch the cos graph between this interval here. Now we can't actually really sketch the cos graph between this interval here because these values are too specific. We like something like this between 0 and 2 pi. But for these values they're too specific in order to sketch the cos graph accurately between. So what we're actually going to do is the best way to do this is to extend the interval slightly. So pi over 5, let's actually do a bit lower than this to 0. And 11 pi over 5, let's actually sketch the graph a bit bigger than this to 5 pi over 2, which are much more manageable values in order to sketch. So let's sketch this. So the cos graph looks like this. This here is -1 and this here is 1. Now, one really quick note I just want to make with this. I think the chance of this coming up is quite small because I think this is a horrible question they could ask. When you extend the interval that you sketch for beyond what the actual interval is, you can get these really annoying answers where they look like solutions on the graph but they don't actually lie in this interval. So for example, the best way to explain this, 11 pi over 5 is approximately equal to 6.9, but the interval that we've sketched to, 5 pi over 2, is approximately equal to 7.9. If we find a solution for theta, this is an example for this question, but just randomly, for example, let's say we've got a theta value of 7.4, which would lie about here. On the graph, this looks like a solution, but you can see that this is actually bigger than 6.9. This is bigger than 11 pi over 5, so it's actually not a solution because it doesn't lie in this interval. It's just because we've extended the interval that we're sketching for that it does look like a solution on the graph. So when you're doing this, if you kind of 11 pi over 5 is about here, and it's the same with pi over 5 here. Pi over 5 is about here. If you get some solutions kind of within this kind of range here, I would say be careful just in case it's like this, where it looks like an interval, where it looks like a solution on the graph, but it doesn't actually lie in this interval. And the best way to do it is to check that 7.4, check what this value is, and it's 6.9. Is 7.4 bigger than 6.9? Yes, it is. So therefore, this is not a solution in this interval. This isn't a solution. It's the same for pi over 5 here. Pi over 5 is about equal to 0.6. If you get a theta value of 0.3, this is not actually a solution in the interval despite it looking like it on the graph. I would be really surprised if this comes up because it's a really horrible thing they could ask, but just in case, have that in the back of your head. Fortunately for this question, so we need to do minus a half. So minus a half, let's say it's about here. We can see two solutions. These are nowhere near the boundaries that I just said here, so we don't need to worry about the thing that I just said. Okay, so we know that this value here is 2 pi over 3 from before, and the way we figure this out is we need to figure out this difference here between 2 pi over 3 and pi over 2. So this is going to be 2 pi over 3 minus pi over 2. And if you put this into a calculator, this is equal to pi over 6. And because of symmetry, this is going to be the same difference here as well between 3 pi over 2 and this solution. So this is going to be 3 pi over 2, this value here, minus the difference here, which is pi over 6. And if you put this into a calculator, this is equal to 4 pi over 3. I would underline these solutions here. Don't be confused about this, thinking this is a solution as well. This was just for working out. That's a mistake I've made before. So therefore, the values of theta plus pi over 5 are equal to 2 pi over 3 and 4 pi over 3. And now what we need to do is we just need to minus pi over 5 from all these values, because remember, we basically just need to rearrange the equation. So for example, if this was equal to 2 pi over 3, we need to move this pi over 5 onto this side here. So what we need to do, we need to minus pi over 5 from both of these. So theta is equal to, and if you put these both into your calculator, you get out values of 7 pi over 15 and 17 pi over 15. So these are the two solutions for theta. And again, you can check your answers by putting these theta values into this equation here and seeing that you get out -1. So put 2, so put 2 cos of theta, which will take this one, 7 pi over 15 plus pi over 5. And if you put this into your calculator in radians mode, you do get out the value of -1. So therefore you know that you have found the correct values for theta. They could ask you to solve an equation with multiple transformations. We talked about how to do this in the harder trigonometric equations part 1 video, and we'll go over it again here. So we need to solve this equation here, and as we've got some inside the function transformations, we need to change the interval first. And what we need to do is we need to times the 2 and then minus the pi over 4, because if we minus the pi over 4 first, and then times everything by 2, that will then become pi over 2 instead. So we need to do the 2 first and then the minus pi over 4. So the interval at the moment is between 0 and pi. So firstly, times everything by 2. So this becomes 2 theta. This here will still be 0, and this here is now 2 pi, and now we minus the pi over 4 again, because if we did the pi over 4 first, this 2 would affect that as well. So we need to do 2 theta minus pi over 4. So 0 minus pi over 4 is minus pi over 4, and 2 pi minus pi over 4 is equal to 7 pi over 4, like this. So this here is the new interval. So now we need to solve this equation, and all we just need to do firstly is do the inverse sine of root 2 over 2, which if you put into a calculator is equal to pi over 4. So I've drawn an axis with a ruler, and now we need to sketch the sin graph in this interval here. Again, because this is quite specific intervals, it's quite hard to draw it in this interval. I'm instead going to draw it in the interval minus pi over 2 on this side to 2 pi on this side. So it's going to start from here and it's going to come up. This is going to be at 1 and this is going to be at -1. And let's say root 2 over 2, let's say it's about here. So there are 2 values, as we can see. The thing that I talked about before with translations, about the kind of uncertainty with kind of these values here and these values here, we don't need to worry about that as it's nowhere near there. So therefore this here is the pi over 4, and therefore the difference here is pi over 4 between 0 and pi over 4. So therefore the difference between pi and this value is pi over 4. So therefore this value is going to be pi minus pi over 4, which is 3 pi over 4. So therefore this 2 theta minus pi over 4 is equal to pi over 4 and 3 pi over 4. Now we need to do it in the order that we normally would do algebraically. Again, you can consider these individually if you want, as 2 theta minus pi over 4 is equal to pi over 4, and then you need to put the minus pi over 4 on the other side and then divide both sides by 2. I just kind of write it together like this. So add pi over 4 to both sides, do 2 theta is equal to pi over 2 and pi, and therefore divide both sides by 2 to get theta is equal to pi over 4 and pi over 2. Again, if you want to do these individually, so you do the 2 theta minus pi over 4 is equal to this one, for example, is equal to pi over 4, and then do the 2 theta is equal to pi over 2, and then divide both sides by 2. You can do it like that if you want to. I just kind of write them together. And then these are the final answers. And again, you can sub these values in as the value of theta, and you get it out root 2 over 2. Very finally, they could give you a slightly more complicated equation that you need to do some working up on first before you get it into the more friendly format that we've already seen in this video that's easy to solve. So here's an example of this. Now, whenever you see tan of x, you should always be thinking of the identity that tan of x is equivalent to sin x over cos of x. So let's sub this in for tan of x here. So this is going to be equal to 2 sin x over cos of x, and then minus 3 sin of x, and this is equal to 0. And then what we're going to do is we're going to multiply everything by cos of x in order to get rid of this in the denominator. Now we can do this because cos of x equal to 0 is not going to be a solution. If it could be equal to 0, we can't really multiply everything by cos of x because we could technically be multiplying everything by 0, and that just doesn't really work. But the reason that cos of x can't be a solution here is because it's in the denominator in tan of x. If tan of x exists in the equation, therefore cos of x is in the denominator, and it can't really therefore be equal to 0 because then you could be dividing it by 0. Remember, you can't divide something by 0. So therefore cos of x can't be equal to 0, so we can times everything by cos of x, so this becomes 2 sin of x minus 3 sin of x cos of x, and then this is equal to 0. 0 times cos of x is still 0. Now, when I was at A level, the mistake that I always used to do here is I would then divide both sides by sin of x here in order to be left with 2 minus 3 cos of x here. But we can't do that here because sin x equal to 0 is a possible solution to this equation. Why is this? Well, you can just see this easily, because if we sub in sin of x 0, if we sub in the solution for sin of x is equal to 0, it becomes 2 times 0 minus 3 cos x times 0, and this is 0 and this is 0, so therefore this would be equal to 0. So then 0 is equal to the other side, which is equal to 0. So both sides of the equation equal each other, they both equal 0, so therefore sin of x is a valid solution. So we can't divide both sides by sin of x because we'd be dividing by 0. Instead, what we have to do is we have to factorize out sin of x like this. So sin of x, then this here would just become 2, and then it's minus 3 cos x here with the sin x going away, and then this is equal to 0, and therefore we have two possible scenarios here. The two possible scenarios is that sin of x is equal to 0, or that 2 minus 3 cos of x is equal to 0. A quick reminder of why this is because in order for this to be equal to 0 and these two things are multiplied together, the only way for two things multiplied together to equal 0 is either this is equal to 0 or this is equal to 0, or technically both of them are equal to 0. One of them has to be equal to 0 in order for two things to be multiplied together to be equal to 0. So these are the two possible scenarios, and we have to solve them individually. So let's start with this one. Sin of x is equal to 0. So the inverse sin of 0 is just equal to 0. So now we need to draw the sin graph between minus pi and pi, so it will look something like this here. And we need it when it's equal to 0, aka when it's a root here, and we can see that this is here, here, and here. Except when you closely look at the inequality, there is no equal to or greater than here. It can only be less than pi. It cannot be equal to it, so therefore this is not a solution because it cannot be equal to pi. So x cannot be equal to pi, so this is not a solution, but it can be for minus pi here because we do have this line underneath. So it could be minus pi, so therefore the solutions for x are 0 here and minus pi. And then for the other equation, 2 minus 3 cos x is equal to 0, let's move the 3 cos x onto the other side to get 3 cos x is equal to 2, and divide both sides by 3 to get cos x is equal to 2 over 3, and then the inverse cos of 2 over 3 in radians is 0.84. And then I've just drawn a quick pair of axes, and now we need to draw the cos graph. So it starts from here, and we'll say that 2 over 3 is about here, and we can see that there are two solutions, and we know this one here is the 0.84, and because of the way the cos graph works and it's symmetric around the y-axis, this here is going to be minus 0.84. So therefore the x values are 0.84 and minus 0.84. So therefore all of the values are these together. So it's going to be 0.84 minus 0.84, 0, and minus pi. I know it says give answers to two decimal places where appropriate, but we can leave this as minus pi here. And then these are the solutions. Now, really quick, remember here when we factorized by sin of x instead of dividing? If you did divide here by sin of x instead, you would only get the 0.84 and minus 0.84 solutions. You wouldn't get the 0 and the minus pi, and therefore you would lose marks. So make sure that you do the factorize of sin of x like this. And again, remember, a good way to check your answers is to sub each of these x values into this equation and seeing that you get 0 as the output. So here's just a couple more radian trigonometric equation questions from past papers that you can have a go at. So pause the video, have a go, and I'll go through the answers in about 5 seconds. So for question 1, we have an inside the function transformation here, so therefore we have to adjust the interval. So at the moment, the interval is minus pi, theta, and then pi. Then we need to minus pi over 5 from everything to get, so this become theta minus pi over 5. And this here will become minus 6 over 5 pi, and this here will become pi minus pi over 5, which is equal to 4 pi over 5, like this. And then we need to actually solve this equation. So this is 1 minus 2 cos of theta minus pi over 5 is equal to 0. I'm going to move the 2 cos theta minus pi over 5 onto the other side to get 2 cos of theta minus pi over 5 is equal to 1. Then divide both sides by 2 to get cos of theta minus pi over 5 is equal to a half. So then we're going to do the inverse cos of a half, which if you put into a calculator is equal to pi over 3. And then we need to sketch the cos graph in this interval here. Now, as I said before, for translations, this interval is quite awkward because it's very specific. So I'm going to slightly expand the interval. So I'm going to slightly expand 4 pi over 5 to pi. And I'm going to slightly expand minus 6 over 5 pi to minus 3 over 2 pi, like this. So the cos graph is, and this here is pi, and let's say that half is about here, and we can see that there are two solutions. This one here is pi over 3, and this one here is minus pi over 3. So therefore theta minus pi over 5 is equal to pi over 3 and minus pi over 3, and therefore theta is equal to, and then we just add pi over 5 to both sides, so pi over 3 becomes 8 pi over 3, 8 pi over 15, sorry, and minus pi over 3 becomes minus 2 pi over 15. And then these are the two solutions for theta, and again you can sub these back in as theta for this equation, and you should get out an output of 0. And then for question 2, this is similar to one of the latter questions that we did in this video, in which we need to do some sort of working up first before we can get it in the format that we're more familiar with, that we can solve. And this is actually a quadratic, and we talked about this in the harder trigonometric equations part 2 video of year 1, so go back to that if you need to. But I'll go through it here. The key to this is by using the identity that sin squared theta plus cos squared theta is equivalent to 1. And what we need to do is we need to either make sin squared theta the subject or cos squared theta the subject, and then sub it in for one of these values. So we only get one of sin and cos. We don't really want both of them because we can't really work with it. If we've got both of them, we only want one of them. So the question is, which one do we sub out? And the key to this is, so the sin squared theta and the cos squared theta we can easily get rid of for the other sin or cos using this, but we can't do this for the non-squared values. And you can see that we only have one non-squared value, which is sin theta. We don't have cos theta, and therefore, because we can't get rid of this, we're going to make sure that we get this in the sin theta format rather than the cos theta format. So, aka we want to get rid of this here, and we can do this by rearranging to make cos squared theta the subject. So this becomes cos squared theta is equivalent to 1 minus, and move this onto the other side, 1 minus sin squared theta, and then sub this in for the cos squared theta. So this equation will become 6, and then cos squared theta will become 1 minus sin squared theta, so 1 minus sin squared theta, minus 5 is equal to 6 sin squared theta plus sin theta, like this, and then expand this bracket here to get 6 minus 6 sin squared theta minus 5 is equal to 6 sin squared theta plus sin theta, and then 6 minus 5 is equal to 1 minus 6 sin squared theta is equal to 6 sin squared theta plus sin theta, and then we're going to move this minus 6 sin squared theta onto this side, so it becomes 1 is equal to 12 sin squared theta plus sin theta, and then we're going to move the 1 onto the other side to make everything equal to 0, so it's a quadratic equation. So it's going to be 12 sin squared theta plus sin theta minus 1 is equal to 0, and then this is a quadratic equation. If you want to, you can make sin theta equal to x. You can see this a bit clearly because then it becomes 12x squared plus x minus 1 is equal to 0. You might be more familiar with it being with the x's like this. And then we just need to solve the quadratic equation. We talked about this in year 1. There's loads of ways that we can do this. We can either factorize, we can use the quadratic formula. I'm just going to use the calculator. So a quick reminder of how you do this. On your calculator, you press the menu/setup button and you go down to the equation/function part, which is A. Press equals on it, press 2 for polynomial, press 2 again for what degree it is, because we're going up to the power of 2, and then sub in the correct coefficient. So it's going to be 12, it's going to be 1, because remember there is actually a 1 here, and then minus 1. And if you press equals, it gives you out what the x values are. So x is equal to a quarter and minus 1 over 3, like this. And as x is equal to sin theta, this means that sin theta is equal to a quarter and minus 1 over 3. So therefore we have got two values that sin theta can be equal to, so we have to solve it for both of them. So let's first start with sin theta is equal to a quarter, and the inverse of a quarter, if your calculator is in radians mode, is equal to 0.253. So now we need to draw a sin graph in this interval here. So it starts like this, and a quarter, we'll say that a quarter is about here, and this value here, and a value here. We know this one here already. This is the 0.253, and we know that the difference between 0 and this value is 0.253, and the difference here, because it's symmetric, is the same value. So therefore this value is going to be pi minus the difference to get to here, which is 0.253, which if you put into a calculator is equal to 2.89. So therefore theta is equal to the 0.253 and 2.89. And now we need to do the other possibility, which is that sin theta is equal to minus 1 over 3. So we do the inverse sin of minus 1 over 3, which if you put into a calculator is equal to minus 0.340. And then we just draw the sin graph again for this interval here, and we want -1/3. So let's say this is about here, so we can see that there are two values. Now the value we've actually got out of the calculator is not actually in our interval. What the calculator has done is it has taken this value here instead, which is fine. We can still use this. Although this isn't a solution, this can be the way that we can figure out the difference here, because this here is -0.340. So therefore the difference between this point and 0 is going to be 0.340. And then what we can do with this is use this difference for these values here. So this difference here between this and this value is also going to be 0.340. So therefore this value here is going to be the pi plus this difference here to get to this value, 0.340, which if you put into a calculator is equal to 3.48. And then this difference here is also 0.340. So therefore this value is going to be the 2 pi minus the 0.340, which if you put into a calculator is equal to 5.49, 94, sorry. So therefore the theta values are 3.48 and 5.94. Be careful not to include this value as it doesn't belong in the interval. And therefore all of the theta values are all of these values together. So 0.253, 2.89, 3.48 and 5.94. So these are the solutions. And again, you can check these by subbing these values into this equation here and getting out the equivalent values for when you do this side and this side.